Okay, in this video, we are taking our knowledge of exponential functions and applying them to tables. So before we begin, there are some things that we need to make sure we keep in mind. The first thing that we need to make sure we keep in mind about exponential functions is that the pattern is either going to be multiplying or dividing. That means it's not going to be adding, it's not going to be subtracting, and it's definitely not going to be something random. As in, it's not going to go up, then down, then back up again. It's going to stay consistent, and it's going to be a pattern of either multiplying or dividing. And remember, a pattern of multiplying tells me that it's an exponential growth, and a pattern of dividing tells me it's an exponential decay. The second thing that we need to make sure we remember before we start looking at tables is the equation format. Y equals A times B to the X. Again, hopefully you're remembering that the A stands for our starting value. Which is the same as your y-intercept. And then hopefully you also remember that your B value is your common ratio. And your common ratio, again, is directly related to your pattern of multiplying and dividing. So let's look at what this looks like. The directions say, determine if each table below is exponential. If it is exponential, write an equation to represent the function and tell whether it is a growth or a decay function. So the first thing we need to do is decide if these tables are exponential. So we have to look at what pattern these tables have. And we want the pattern to either be multiplying or dividing. Well, when I look at table 1, the first thing I notice about all these output values is that they start at a small number, 2, and get to a large number, 162, very quickly. And I know that exponential functions grow very quickly. So I'm hoping that this is going to be exponential. So I'm going to look from the number 2 to the number 6 and see if there's something that will easily multiply from 2 up to 6. Well, I know that 2 times 3 makes 6. So now I'm going to look at the next set, 6 to 18. Oh, 6 times 3 equals 18. Same thing with 18 times 3. It makes 54. And 54 times 3 makes 162. So I do have a consistent pattern of multiplying. So this is an exponential function. Let's look at table number 2. I'm looking at my output values and trying to find a pattern. Now again, we want the pattern to be either multiplying or dividing for it to be exponential. But in this case, I started at a pretty small number and I ended at a pretty small number. 2 to 10 is not very big of a growth. So I'm doubting that it's going to be exponential, but let's check anyway. From 2 to 4. Could I multiply easily from 2 to 4? Yeah, well that's times 2. Now does 4 times 2 make 6? No, it doesn't. 4 times 2 doesn't make 6. So I'm going to see if I can find another pattern. Well, 2 plus 2 will make 4. 4 plus 2 will make 6. 6 plus 2 will make 8. And 8 plus 2 will make 10. So this time I did have a pattern, but it's a pattern of addition. So this is not exponential. Okay, exponential functions are either multiplying or dividing, not addition, not subtraction. Let's look at the next two tables. I'm looking at my outputs, and I see that I'm starting at 50 and ending at 12, so I'm pretty hopeful that decreases pretty fast. But let's see if we can find a pattern of either multiplying or dividing. Well, from 50 down to 40, well, I don't know something that easily divides 50 to 40, but I do know that I could subtract 10 to make that happen. 40 to 35, well, that would be minus 5. 35 to 28 would be minus 7. 28 to 12 would be minus 15. This table doesn't have a pattern at all. No adding, no subtracting, definitely not multiplying or dividing. So this table is not exponential either. Table number 4. I started at 8, went down to 0.5. So I know it's decreasing, but I want to know by what. And hopefully it's multiplying or dividing. Well, 8 to 4, I could divide by 2. 4 to 2, also divide by 2. 2 to 1, also divide by 2. 1 to 0.5, that's also divide by 2. So I do have a pattern, and it is a pattern of dividing. So yes, this is exponential. Now we're going to go back and look at just the two tables that were exponential functions, because our directions tell me that if it is exponential, write an equation and tell whether it is a growth or a decay. So in problem number 1, I need to write an equation. So I need y equals, I need to put my starting value first. To find your starting value or your y-intercept, you're looking across from the 0. So I had 2, and then my common ratio was 3 because I multiplied by 3 every time. And this will be a growth function because my common ratio was bigger than 1. Let's look at our other table that was exponential and try to write an equation for it. Y equals, I need my starting value. Again, your starting value is across from 0. Notice how in this table, it was not the top row of my table. Your starting value is not always on the top, but it is always across from 0. So my starting value was 2. My pattern was dividing by 1/2. So I need to put the fraction 1/2 inside my parentheses. And since my pattern was dividing, or because my common ratio is less than 1, this is going to be a decay curve.